Are you still using clunky for loops to filter your data? Stop, you're writing more code to get slower results. Look at this. In just a few lines, we've transformed, filtered, and optimized our data pipeline. Today, we're mastering Pythonic data filtering using list comprehensions and generator expressions. Let's dive in. See that? Clean, readable, and highly efficient. But to truly understand why this is better than a standard loop, we need to build it from scratch and look under the hood. Let's clear this out and start from zero. First, we need the sys module to track memory usage. This is a crucial skill for medium-level devs, knowing not just if your code works, but how much it costs the system. Now let's define a realistic dataset. Imagine we're building an e-commerce backend. We have a list of products, each with a name, price, and stock level. Notice how we keep our lines short and readable. The old way to filter this would be to create an empty list, loop through products, check conditions, and then append. That's at least 4 to 5 lines of boilerplate code that obscures your actual logic. Instead, let's use a list comprehension. The first part of a comprehension is the expression. This is what happens to each item. Here, we're grabbing the name and converting it to uppercase. Now we add the iteration part. And finally, the filter. We only want items where the price is over $100 and the stock is greater than 0. This single block of code replaces the entire for loop structure. Let's print our results to make sure it's working as expected. In Python, comprehensions are actually faster than manual loops because they are optimized at the bytecode level. It's not just prettier, it's better performance. But what if your dataset has 10 million items? A list comprehension creates the entire list in memory immediately. This can crash your server. That's where generator expressions come in. Watch the syntax change. It's subtle but powerful. By simply using parentheses instead of square brackets, we've created a generator. This doesn't calculate anything yet. It's lazy. It only computes the next value when you actually ask for it. This is how you handle big data in Python. Now let's prove the difference. We'll print the memory size of both. Even with this small list, you'll see a difference. On massive datasets, the gap is astronomical. One is a fixed size, the other grows with the data. One more advanced trick: what if you need an else condition? You can use a ternary operator inside the comprehension. Let's tag items as premium or budget based on price. Notice the order here. If you have an else, the condition moves to the front. This is a common source of confusion for developers. If it's just a filter, the if stays at the end. If it's a transformation, it goes to the front. Let's run this final version and see the magic happen in the terminal. Look at that memory efficiency and the clean output. You've just leveled up your Python game from beginner to professional. Beautiful, we've got our filtered list, our memory metrics, and our conditional tags. Remember, use list comprehensions for small to medium lists where you need the result immediately. Use generators for large-scale data processing to keep your memory usage flat. If you found this helpful, screenshot that code and follow CodeVarsity for more senior-level Python tips. Happy coding. Sharpen your skills on the go. Download CodeVarsity today from Play Store for premium courses, curated YouTube hubs, and interactive practice snippets with built-in IDE.